Welcome back, Pre-Calculus. I hope you all are well. Today's objective is going to be to graph polar equations and start to recognize some of the properties of their graphs as well. I'm going to force a pause on your screen. You know what to do from here. All right, I'm going to force another pause on your screen. Can you please try this warm-up for me? Try to convert this polar equation to rectangular form. My hint is to use a reciprocal identity for secant of theta. So remember, secant of theta is 1 over what? 1 over cosine of theta, and then see if you can get it to just x's and y's from there. Go ahead and hit continue when you're ready to see the answer. Alright, so if you got this far, then you've got it into rectangular form. If you went ahead and completed the square to get into standard form, we should have gotten there, but we would take either answer there. So this is a what shape? This is a circle centered at 4, 0 with a radius 4. Okay, I'm going to force a pause on your screen. Go ahead and do two things for me. Copy the equation for example 1, and then make this table for me. We've got theta going from 0, pi over 6, pi over 2, 5 pi over 6, etc. So your radians with denominators of 2's and 6's. And so make this table for me, and then go ahead and hit continue when you are ready to start it together. Okay, we are back. So we're going to fill in this table. We did this last time. So when theta is 0, then I would get r equals 1 minus 4 times sine of 0. What is sine of 0? Sine of 0 is 0, so I have 1 minus 4 times 0, which is 1, right? So I'm going to put that in there. Okay, let's try pi over 6. So I've got r equals 1 minus 4 times sine of pi over 6. What is sine of pi over 6? Sine of pi over 6 is 1/2. So I'm going to have 1 minus 4 times 1/2, which is 1 minus 2, which is negative 1. Okay, so I'm going to put that in there. All right, would you go ahead and complete the table for me and hit continue once you've done that? All right, so now we're going to try to sketch this graph by hand. Double check your table, make sure it matches mine. And if you've got polar graph paper in front of you, go ahead and take that out and let's start plotting some points. Otherwise, I'm going to, in just a bit, give you a link to a Desmos where you can drag and drop some points. So if r is 1 and theta is 0, I would be at an angle of 0, but I would be on with a radius of 1, so we would be right there. Then I've got pi over 6 and negative 1 for r. Well, if I go to pi over 6 and positive 1, we would be here. And then the negative 1 for radius is going to do what to that angle? Or to that point, I should say. Yeah, it's going to shoot it across the origin or the pole, right? So we should be there. Okay, so go ahead and plot the remaining points. Now, if you do not have polar graph paper in front of you, I'm going to send you this link. I've got tons of movable points here that you can just drag and drop. So like that first one, we should be at a radius of 1, angle of 0, and so on and so forth, right? So you can just drag and drop there. Okay, so you go ahead and fill in the graph either on Desmos or on your polar graph paper, and then hit continue once you've got all those plotted. Okay, we are back. All right, so here's what I got for my points. Go ahead and pause the screen if yours don't look quite like this, and make sure that you've got the same points I do. Now, when we're going to connect these, it's really important that we think about what order we plotted them in. So watch my mouse. We started here, right? And then we went to this one, then we went down, around, back up, and then back down and around again, like so, okay? So let me see if I can graph this for us. Something like that, okay? And on Desmos, which does a much better job than Mrs. Peterson, looks like that, okay? Good deal. All right, I'm forced to pause on your screen. We're going to talk about some vocab here next. Okay, so for the x-axis, which is what we'd call it in rectangular form, we call this the polar axis. In polar form, okay? The y-axis, we actually put the equation on here, which is theta equals pi over 2, right? If I were to graph that, this would give me that vertical line, or the y-axis. So again, we just call this the line theta equals pi over 2. Instead of calling it the origin, we call center there the pole. Okay, so just some vocab for you there. All right, nothing for you to write down here. We just want to kind of talk through these graphs together. We're going to look at symmetry, okay? And we're just really just going to look at the graphs and talk about, are they symmetric with respect to the polar axis, the line theta equals pi over 2, or the pole, okay? And they could be all of those, none of those, 1, 2, etc. Okay? So let's take a look at this first one. Is it symmetric with respect to the x-axis, also known as what in polar form? The polar axis, right? So do I have the same picture above as I do below that line? I do not, right? So not symmetric with respect to the polar axis. Okay, what about, is it symmetric with respect to the y-axis? This one's very, very difficult for me to do. Here, we'll do it this way. Is it symmetric with respect to the y-axis, also known as what? The line theta equals pi over 2. So do I have the same picture to the left of that line as I do to the right of that line? I do, okay? So this is symmetric with respect to the line theta equals pi over 2. Okay, and what about, is it symmetric with respect to the origin, also known as the what? Also known as the pole. And one way to check this is if I rotate this 180 degrees. In other words, if I flip this upside down, do I have the same picture? What do you think, yes or no? I don't, right? I have, if I look at it this way, I have more of the circle on the bottom. Now I have more of the circle on the top, right? So this is only symmetric with respect to the line theta equals pi over 2. All right, let's try the next one. Symmetric with respect to the polar axis. What do we think? Yes or no? Yeah, I would say yes, symmetric with respect to the polar axis. What about symmetric with respect to the line theta equals pi over 2? Not in this case, right? And then is it symmetric with respect to the pole? Well, look at it now. I've got one petal on the positive x-axis, right? If I rotate, do I still have one petal on the positive x-axis? I do not, right? So this one's only symmetric with respect to the polar axis. Okay, I'm going to force a pause on your screen. You decide which symmetries this last graph has. All right, this last one is only symmetric with respect to the pole or the origin. Again, if right now I've got like a loop in quadrants 1 and 3. If I rotate this guy, let's see if I can do that. I still have a loop in quadrant 1 and 3, so this looks good. Just so you know what my math lab will say, it will word it like this, just replacing r comma negative theta confirms symmetry. All I want you to, what we want you to know is, can you look at the graph and discover symmetry that way? So just pop onto Desmos or on your graphing calculator, type it in, and decide the symmetry from the graph, please. Force a pause on your screen. Can you please copy this equation here? Okay, so our second feature is going to be to determine the max value of the absolute value of r, as well as zeros, okay, of r. So for the max value, I really want you to focus in on the sine theta or cosine theta piece of your equation, okay? So in this case, I've got cosine theta right here. Now for sine and cosine, if you think about either their graphs, like those wave graphs, or think about just in terms of general trigonometry, what is the max value that I could get for cosine of theta? My max value is 1, right? If you think about that curve, it just goes up and down. You've got an amplitude of 1, so my max is 1, and what is your min? It's -1, okay? So when I want to test what is the largest option I could get for my output here for the absolute value of r, all we have to do is replace that trig piece, either the cosine or the sine part, with 1 and -1, and take the absolute value, and the largest one wins, okay? So if I replace cosine of theta with 1, I get 6 minus 12, which is -6. If I replace cosine of theta with -1, I get 6 plus 12, which is 18. Taking the absolute value of both of those, I get positive 6 and positive 18. So the winner for the max value of the absolute value of R is 18, okay? And basically you're doing a candidate test here, right? Like the biggest that part could be is 1, the smallest it could be is -1, and that negative here, of course, can alternate it, okay? So our max value of the absolute value of R, we got it's 18, and then it says for which theta value does the max occur. So now I'm going to substitute 18 in for R, and I'm just going to solve for theta. Okay, so let's go ahead and subtract 6 from both sides. Divide both sides by -12. So I'm getting cosine of theta is -1. So for what angle is cosine equal to -1? That would be theta equals pi, right? At 180 degrees or pi radians, the x value here is -1, and cosine is the x-coordinate on the unit circle. So that is where the max value occurs. All right, would you try one like that on your own? Now go ahead and write R equals 1 plus 23 sine theta and find me the maximum value of the absolute value of R, and then also for which theta that max value occurs. All right, I got 24 for the absolute value, for the max value of the absolute value of R, and I got that occurs at theta equals pi over 2. If this is not what you got, go ahead and pause your screen and correct anything you need to. All right, can you go ahead and copy these in your notes? And then once you've got them copied, I'm also going to put a link for a Desmos URL, and go ahead and go to that link as well in another tab. All right, so I want you to go back to that tab in just a moment, and what I've done is I've put the same equations, like graph 1 is the first one from here, right? Graph, we can collapse that. Graph 2 is the second one. Graph 3 is the third one that you wrote down. And what I'd like for you to do is first go ahead and turn on graph 1. And then I just want you to kind of slide your A's and your B values and just write down anything you notice or wonder what happens, what patterns are you seeing, basically, okay? And then once you've got that written down, go ahead and mark or unclick that, collapse graph 1, and then do the same thing for graph 2, and then the same thing for graph 3. All right, now if you go to Canvas, you don't have to do this right now, but there's a page there called Polar Curve Summary, and we've got all this kind of outlined for you. You do not need to memorize any of this. This is just kind of to help you spot patterns as you are going, and maybe you saw a lot of this already. So let's start over here, because we started here with this RE equals A cosine. They're using N, theta I used B. Notice that you got N petals if N was odd, but you got 2 N petals if N was even, right? So we've got some examples here. 5 cosine of 3 theta, so you notice 5 is going to be your max R value, and then with 3 theta, you're going to get 3 petals. Now, if you've got 4 cosine 6 theta, now 4 is your max R value, but if you've got 6 theta here, how many petals are you going to have? You have 12 petals, okay? And we've got similarities for sine here. Notice in general, if you're dealing with a cosine function, then you're typically going to have symmetry with respect to what? With respect to the polar axis, whereas if you've got a sine function, you're typically going to have symmetry with respect to the line theta equals pi over 2, okay? Now, if we come up here to the limicons, you can have a limicon with an inner loop, which was kind of like that first example we did when we graphed by hand. You can have a cardioid, also known as a heart, right? You can have a limicon with a dimple or a convex limicon, all right? And this all depends on how A and B are related, where here's your A value and here's your B value, okay? And then we've got circles as well and lemniscates as well. All right, and force a pause on your screen. Just go ahead and write these 2 equations in your notes, please. So for our final example, we just want to determine any of the symmetries, which we've already talked about, and then also find the smallest theta interval that's going to produce the complete graph. And we're going to do all of this on Desmos. And so let's go ahead and pull up. All right, so I've gone ahead and typed them in for us already. Remember, if you want to type in theta, I think the easiest way is to just write the word theta, T-H-E-T-A, and that will change it to theta for you. Okay, so before I turn on r equals 2 sine theta, looking at if you've got, now let's do it here. From here, what do we think this curve will be? This is going to be a rose curve, and how many petals do you think we're going to have? We are going to have 3 petals, right, because n is odd. And what kind of symmetry do you think we're going to have? Let's take a look. So we've got symmetry with respect to what? The line theta equals pi over 2, in other words, the y-axis, and that's the only type of symmetry we have here. Now, the other question said, okay, for what theta interval, what's the smallest theta interval you need to graph to basically get the whole picture? What is so nice about Desmos is it just does it for you. So it just tells you here 0 to pi, that is how far you need to go. After that, you'll start to get repetition, right? You'll just keep producing that graph over and over. Let me show you, like if I go to 2 pi, I still have that same graph, right? But if I only go to pi over 2, I only get half the graph. So Desmos just fills this in for you right away, and it just spits out the answer for you right there. Not the case on the 84, though, all right? Okay, so the second one, this was not in our list. I'm going to go ahead and turn it on. So what kind of symmetry would you say here? I would say all 3, right? So symmetric with respect to the polar axis with the line theta equals pi over 2 as well as the pole. And the smallest theta interval that's going to produce the full graph is 0 to 2 pi. Again, Desmos just did that for us, okay? All right, you all, that is what we have for today. We will see you next time.